Hello everyone, my name is Alyssa Ferri, and today I'll discuss the research I completed as a master's student at the University of Arkansas. So as we all know, anthropogenic eutrophication is exacerbating the magnitude and longevity of effects felt from harmful algal blooms. Harmful algal blooms primarily consist of cyanobacteria, many of which are able to produce cyanotoxins that serve as health risks for human and animal populations. Cyanotoxin production has also been shown to vary widely during one sampling season and between many years. So, the objective of this study was to observe the variation in temporal water quality data and to create a predictive model with parameter thresholds and a hierarchy structure in relation to total microcystin concentrations. So Lake Fayetteville was originally created to be a drinking water source before Beaver Lake, but now serves as a recreation source. Water samples were collected from the lake from 2019 through 2021, and 8 parameters were measured. 4 models were then constructed using a classification regression tree analysis in R. For the temporal results, we will look at the graphs in the middle. There's a lot of data there, but I have a few key points highlighted. For nitrate plus nitrite on the second graph, in the first year of the study, concentrations were detectable during toxin production, whereas in year 2, concentrations were non-detectable. Then moving on to the phycocyanin to chlorophyll ratio on the fourth graph, while we did not have the cyanofluor in 2019, a similar bimodal pattern emerged in both 2020 and 2021. And then finally, for total microcystin on the fifth graph, 3 different patterns were observed each year. In 2019, we observed quick spikes of microcystin with individual samples violating the US EPA guidelines of 8 micrograms per liter. In 2020, there was a more sustained production, but at a lower concentration. And then in 2021, there were those quick spikes of microcystin, but lower in concentration. And then moving on to the regression tree models, which is on the right side. The main takeaway here is that each individual model is slightly different than the all years model at the top, with 2020 having the most influence. Using the all years model, the conditions needed for the greatest average microcystin concentration was that the water temperature needed to be greater than or equal to 27 degrees Celsius, the year had to be 2020, the chlorophyll raw fluorescent units from the phycocyanin to chlorophyll ratio had to be greater than or equal to 3,600, and the total nitrogen to total phosphorus ratio had to be less than 51. And overall, this model accounted for 60% of the variability in the total microcystin concentrations. So what was the takeaway from all this? Well, a single predictive model for when total microcystin will be greatest would be hard to develop because of the variation in water quality parameters across many years. Thank you.